This is my second video on designing and building an ROV, which is basically just an underwater drone. And so I designed this and I built it out of PVC fittings mainly. These are T's and some PVC pipe. So I went with a couple different sizes here. And so I come up with this design because I had seen several videos on DIY ROVs on YouTube, and they were really cool. All of them are pretty cool. But some of the designs, they just used tubing like this and elbows, and they'd end up building like a box. And a lot of them had a lot of pipe and stuff that I wanted just to eliminate all the extra pipe that they were using, because it causes drag. As this moves through the water, I wanted the least amount of drag as possible, and I wanted the design to be as simple as possible. So this is what I came up with. And like a lot of ones I've seen on YouTube, they'd have more pipe going across like here and down here, and you know, it's a lot more weight, more drag. And then they'd just get PVC tubing and put caps on them, and the tubing is smaller and then the caps are bigger. So I decided to go with this route and just use these T's and caps. That way it's all flush, and not like these are bigger and then this part's smaller and then this part's bigger again, because again that'll cause drag. And this just looks really nice. So I did that with this, and then the bottom part here too is all flush. So the end plugs on these plugs were a little bit bigger. I don't know why. These plugs on the ends fit perfect, but these are a little bit bigger, but it's okay. They're close enough, and it looks okay. So yeah, the whole reason for this design basically was to make it as simple as possible and to have the least amount of drag, so it'll use less energy and be more efficient and actually faster going through the water. So so this is where I'm at right now, and in my first video, which is my last video on this, I put this all together so you can see how I did that in the previous video. And so now I have these motors here, and they have props on them, so they're just like little boat props. And so I've got 4 of these motors, and 2 of them that I have are actually 2 of them are clockwise, run clockwise, and 2 of them run counterclockwise. So the blades on the props are opposite, and they span in opposite directions. The reason for that is that you can use motors that spin in the same direction, and I'm sure it'll work fine. I think that's how most people do it, but I was lucky enough to find these on eBay or Amazon. I can't remember which one I got them off of, but any rate, so I have 2 of them that will run in opposite directions, and the reason for that is the torque of the motors, because when the prop spins one way, the motor tends to want to spin the opposite direction. And so like a twin engine airplane, the props don't spin like this, they spin like this, and that counters the torque. So that's what I got here. So I'm going to have 2 motors that go in the back here, and the wiring is going to go up and into this tube here. So the motor is going to go in like this. I'm not going to put the wiring in now. I'm just going to kind of bend it around so I can put the motor in so you can see where it goes. So that's as far in as it goes. So I'm going to have to figure out a way to attach the motor into this tube. This tube pulls apart. So this top part I glued together, and this is all watertight. But the lower parts here, I didn't glue them. So I can take them apart in case I want to redesign this. And so they're not glued, they're just stuck together. Now, I may have to through bolt them with little stainless steel bolts to keep them together, because when this gets in the water and the water's cold, and as it goes down, I'm designing this to go down 150 feet. So the cold temperature and the pressure and everything, these might start to come apart because they're not glued. So I may have to through bolt them. I hope I don't have to. They're stuck in there really tight, so they might be okay. And but I'll find out. And but I'm gonna have to figure out how I'm gonna attach these motors, because they got to be really strong because of the torque, and also I don't want them falling out when they're in the water. So what I'm probably going to use is, I'm thinking, because this collar comes off, I'm going to just glue the motor in, probably with something like, there's a product called Shoe Goo, and that was the original product. It was for fixing tennis shoes. But it's also called, I've seen it called Household Goop and different names like that. And you can get it at the hardware store. So it's like kind of like model glue, but it's real thick, and it's super strong, super water resistant, waterproof. If you want to seal anything waterproof, it works really good, and it'll stick to anything. And so I may just glue these in, and then because these motors, you can't service them. It looks to me like it's shrink wrapped, but it would be, I mean, I could probably cut the shrink wrap off and take it apart and then shrink wrap it back if I needed to work on it. But I look at it this way: if the motor goes down and stops working, I'll just replace the whole thing. And I'm not sure if these motors are going to be powerful enough to run this, especially at 150 feet, because I'm going to get line loss in the wires that go from the drone to the power supply, which is going to be my big lithium house battery. I'm hoping it's going to run everything that's on here. And I'm going to put, I have a GoPro camera that's going to go on here, and I also have a fishing camera that's going to go on here. So it's going to have two cameras. The fishing camera, I can see live with the screen. So it has its own screen in this box that opens up, and it's a little screen like this. But what I want to plan on doing is hooking the camera up to my flat screen inside the boat here, and then I will run this drone from inside the boat, but the drone will be outside in the water. And the reason for this drone, basically the main reason, is so I can inspect the bottom of my boat without going in the water. So I can look at any part of the underwater surface of the boat, check the prop, check the zincs, and just check the cleanliness. Also, I made these two plugs in the front. These plugs come out, and then I can build with tubing, probably bigger diameter than this. This is 3/4 inch, and these are 1 inch. So probably 1 inch tubing, which I have some extra. And I'm going to build a scraper, so hopefully I'll be able to scrape and clean the bottom of my boat with this, and that'll be really cool if I can make it work. So that's going to be interesting to see if I can do that. I think I can do it. I really do. But we'll see. So at this point now, what I have to do is, I got these motors figured out. They're going to go in here, so like that. So two of those. Now I'm going to put in two more motors pointing up here in the middle. And the reason for that is this one motor in the middle will push the ROV underwater. So this is going to control the depth. And then the second motor, so there's going to be two motors. The second motor is going to be in the back here, and it's going to be also facing up. So both motors, let me get my other motor here so you can see what I'm talking about. So two motors. This one's got a metal bracket. I removed it off of this one, and this is going to come off. I'm not going to use the metal bracket. But so the two motors, I'm going to have one in the center, and it's going to be down here, and one in the back, and both pointing up. So this one's going to push. They can both push the ROV down underwater, and they can also bring it back up to the surface. But the ROV itself, hopefully when I get everything on here, it'll float. It needs to have slight positive buoyancy, so it'll float up on its own in case the power goes out, I lose power, and it'll float back up to the surface. But you want it to barely float, because if it floats too good, then it's going to take a lot of power to get it to go underwater and keep it down. Anything that's buoyant, the deeper it goes, the more buoyant it becomes. And so as this thing gets deeper, it's gonna take more power to keep it down. And so and that has to do with the density of the water, and that plays in, I guess, with the water temperature. Somebody I seen, I don't know where, on YouTube or something, was talking about, oh, you can't compress water, which is true, but as far as I know, and then also, so they say, well, the pressure comes from the temperature of the water. Well, I have to debate that, because if it's the temperature that causes high pressure in water because you can't compress water, then I know for a fact, because I've taken a ball and pushed it down to the deep end of a pool, and the ball started to collapse, and the farther down I got, the harder. That damn train. Every time I start, it starts. Hate that thing. So anyway, I pushed the ball down into the deep end of the pool, and the farther down I got, the harder it was to push it down. The buoyancy was just real intense. It just wanted to keep coming up. So, but I have to debate the temperature thing, because if it's the temperature that causes the pressure, well, I can see a lot of pressure. This goes down 150 feet. There's going to be a lot of pressure down there. And, but if I went to a frozen lake and broke the ice and stuck this in ice water, about a foot underwater, this is not going to have the same pressure as being 150 feet down. So it must be a combination of temperature and depth that causes the pressure. I guess the temperature makes the water more dense, so the colder it is. So I don't know. So, but I do know the farther down you go, the more buoyant things become. So anyway, but so now this one in the middle, basically I'm going to be using it to push the drone down underwater. And like I said, I can use both of them if I want to. But the main reason for the one in the back is because I want to be able to tilt the drone, especially nose down, so the cameras can look down towards the seabed. If it's flat out like this, then the cameras are going to view out like this. But if I want to look straight, more down at the bottom, then this motor I can control. Now, all these motors, I'm going to have speed controllers on every one that I can separately control the speed of each motor. And so I'll be able to tilt it down. And then if I build a manipulator arm on here, which will be able to pick things up, it'll be in the front here in the center, then then I can drive down and with the manipulator arm pick things up off the bottom of the seabed in case I drop something overboard or I'm doing some treasure hunting, which sounds like a lot of fun. So that's what I got to do now. So now I had to figure out how am I going to do these motors. I got the back motors figured out. That wasn't a problem. So I'm just going to have to glue those in, I think. I can't think any other way to make them stay. I wish there was a way I could just use screws and screw them in, and I'm sure there's a way, but and I still might come up with something, but I think just gluing them in is going to work fine as long as I get them in there straight. And so now these motors, the ones pointing up, how am I going to attach these? So I had to figure that out. I first thought about using a couple of T's and having a T here on this front one for the middle motor and another T back here for the back motor. And but the problem with that is the wiring. Now this front motor here, I'm going to have it. It'll be best if I can keep the wiring all together, as close together. So I decided instead of using two T's, I'm going to use a cross. So this is a cross, and it's this one is it's 3/4 inch, I think. No, wait a minute. Hang on. Is this 3/4? Yeah, it's 3/4 inch. So it's going to go in the back here. So 3/4 inch, and then I got a couple of these elbows. So what I'm going to do is I'm going to have the cross is going to go into, I'm going to have to cut this PVC tube here and put the cross in. So it's going to be in here, but down lower, like that. And put right here. And then this elbow, which is a 3/4 to 1 inch elbow, and I had to get 1 inch so the motor will fit inside. So this is going to be attached back here. And then the motor will go inside of here, like that. And same thing, I'll just glue it in. So I'll have one motor in the back, and then another elbow in the front, and for one motor in the center. Now the center one, this motor is too far forward. It's going to be too far forward. So what I'm going to do is on this side, I'm going to cut this off and make it shorter. And then I have to, it has a little stop, so the pipe will only go in so far and then stop. And so I'm going to take my Dremel tool and Dremel that stop out so I can put this tube in all the way in farther, and then that way it'll hold, because once I remove this piece here, it's not going to have much that I can glue the tube to. So I'll probably this parts will have to be glued together. And what I'll do is this will probably have to be glued in, because the motor, you know, is going to create pressure depending on which way it's going, and I don't want it to make this start to move and turn on me. So it's going to have to be glued in tight. And then what I'm going to do is these connectors here, so I can take this apart like this. I'll probably just through bolt these, so with 4 bolts, 1, 2, 3, 4, through bolt these, so I can take these apart. That way if I store this, I can take it apart and make it smaller. Being on a boat, you don't have a lot of space, so you want to make things compact. So right now I'm going to cut this this end off. I got a pipe cutter here, and this cuts PVC tubing, but it doesn't cut real straight, and I can't get in here, I don't think, to cut this. No, it's not going to get into where I need it, so it's just ratchets closed. So that train never shuts up, I'm telling you. Okay, so what I'm going to do is I'm going to put some tape on here so I'll know right where to cut. See if I can cut the printing side off. It might look a little better. Okay, so I'm just going to take some masking tape and I'm going to go around. Let's just pull off a piece and cut it off. Okay, so now I know where to cut. So I'm going to cut between the white part here and the blue part. So right along the edge of this tape, I'm just going to cut this off. So hopefully I can get it straight. Okay, let's see if I can do this now. Let's take my time. Sure it's going to work. Okay, so that looks good. Yeah, that's pretty good. I think it'll be fine. That should work fine. And I'm just going like that. So yeah, I think that's fine. So I have one elbow here and another elbow like that. So this is going to be for the middle, and it's going to be on the back. And you can see all the wiring will go now into the tube. So the wiring is going to be all hidden and protected. So yeah. And then another thing is the tether, the cable that's going to control all this, has to be attached to the drone. So it's going to attach here. This is going to be in the very back of the drone. So this is a really good spot for it, and there's space for it. So I can drill a hole here, and then what I want to try to get a waterproof connector so I can connect everything. The only thing I'm worried about is the line loss, if I'm going to get line loss with that connector. And I'm going to have to cut my fishing camera cable, so I can have it connected, because it's permanently connected right now to the cable. The camera is, you can't disconnect the cable. So I don't want to have to take the camera off of the drone every time I store it. I want the camera to stay on the drone. I want everything that's on the drone to stay on the drone, and just be able to disconnect it in the back here. So yeah, so let's grind out the center part now. I got to grind out this little stop area. Okay, it's going to work. So this goes in here now, and I'll just have to glue it in with some PVC glue. Make sure I get it in straight. Okay, so that looks good. Okay, let's see how that motor looks in here. Like that. So yeah, no, that's going to work fine. Now I got to do the other one. Now the other one I don't have to cut down, so this is going to glue on this way. And so this will be easier to put on. And that's all I need right there. And this will be done. Okay, there you go. So now this is going to go in between here. This is going to go like this. See how this lines up now. Yeah, that looks good. Just right. Perfect. Perfect. I'm thinking this is a little wide. The wider it is, the more stable it's going to be. But I could make it a little narrower. It's not going to be as stable this way. But it'll be a little smaller. Smaller is better when you're on a boat. And put this one in its place. Okay, I can make this a little smaller. I'm going to cut another tube, and this is going to be a little bit more narrow, so I think it's going to look better. So what I'm going to do is I'm going to make this a little bit shorter. Let me put the back in first. That way I'll know how far to go with it. Let's see what I can do here. Oh, that looks better already. I think I like that. That looks right. Okay, so I don't know, it might be strong enough I won't have to glue it. So I'm going to shorten one of these tubes down. Oh yeah, it's quite a lot narrower. It looks better though, it looks right. So, okay. Cut it right here. So I'm going to make it about 1 inch shorter, I think, if I'm thinking right. Oh yeah, that looks better too. It's looks right now. It's a little narrower, which is good. And but there it is. So one motor here, one motor here, one motor here, and one motor here. And that's how it's going to work. And that's going to be all I need to drive it. And so I'll be able to go down with the middle motor, pushing it down. Then I can go with the 2 back motors. I can go forward. I can go reverse. I can make one motor go forward, the other one go reverse at the same time, so it'll turn on a dime. Or I can do big sweeping turns. And with the motor in the back, I can tilt down or tilt up. So that's all I need. And I can pretty much do anything I need to do with this. This is cool. Damn thing's heavier than hell, and I don't know if it's going to float now. When I put it on my first video, I put it in the water without this piece in here yet, and it floated. The water line was right in the middle of this float. With the 4 motors and the 2 cameras and the wiring, I don't know if this is going to float. If it doesn't, I'm going to have to add some kind of flotation to it. I hope I don't have to do that because it's going to be ugly and it's going to kind of ruin the hydrodynamics of it. I might be able to put foam, just foam, flat pieces of foam in on each side. It's probably what I'll have to do if I have to put foam on there. I hope not. But I will put it in the water here in a minute and see. if it's how it's going to float. So now, yeah, so that's it. So the motor go in like that, and the wiring's going to be all inside and hid, and then the wire connecting to the control unit is going to come off right off the bottom of this elbow. So that's perfect, right in the back. Sticking out here. Okay, so this is what it's going to look like with all 4 motors. Just like that. There you go. Nice. So, will it float? I'm gonna go put it in the water right now and see if it floats, but I'm gonna take these motors out because I don't want them to fall out and sink to the bottom of the bay here. So I'll just leave these 2 top motors in and see if it's gonna float. So let's give it a try. Okay, there it is, it's floating. And I just pushed down on it with my hand, so I think it's going to work great. You can see it's still floating pretty high, and when I put the other 2 motors and the cameras on, I think it'll float right at the surface. But that's what you want. You want very little positive buoyancy, just enough so it'll float up on its own. So there you go. It's looking good. All right. Okay, so I just did the float test, and I removed these 2 motors because I don't want them to fall out and lose them. But I did leave these motors in, and it floated. The water line was right about here, and I pushed it down with my hand, and I can tell by the buoyancy that I think this is going to work. I don't think I'm going to have to add any more flotation, which is a good thing. So I may glue this T here, these together, and that'll be more air will be trapped up in here for more flotation. So I may do that because I was getting some air bubbles coming out a little bit on one of these elbows, so the air was coming out. That air is what's making it buoyant. So it's like taking a cup with nothing in it, turning it upside down and putting it into a tub of water. The air gets trapped in there, and it'll be buoyant as long as you don't turn the cup over. Then the air will come out. So that's how this works. It's not going to be totally airtight, just the top part. So water is going to be in the lower tubes, and then so if I glue this, that'll make the air down to here, which will give it more flotation, which I may do. I'm not sure yet. And but at any rate, this is my design, and I've seen a lot of the ROVs that were DIY, do-it-yourself ROVs on YouTube, and as far as I'm concerned, I think this is the coolest one yet. A lot cooler than the other ones I've seen, but we won't know until we test it. So, whoops, lost a motor. So there you go, and that's it. So if you found this video to be helpful or entertaining, please like and subscribe.